Assalamualaikum and good day. In this video, we are going to look at binary isomorphous phase diagram. Isomorphous means it is complete solid solution. It means that the two elements will completely combine and form single phase in the solid solution. As mentioned before, isomorphous means complete liquid and solid solubility. Only one solid phase forms. The element must have same crystal structure and the solid form will produce the same crystal structure. For example, over here, we take copper-nickel system. This is the binary isomorphous phase diagram for copper-nickel system. As we can see in this phase diagram, it only have two phases. The first one is liquid phase and the second one is solid phase. The diagram have three different phase field, or we call it as regions. The first region, we have liquid only. The second region, we have liquid and solid. The third region, we have solid phase only. For this phase diagram, we denote the solid as alpha. For some example, we also use SS as solid state. We can also use beta and many more. It is depend on the example or the question. Other than that, we also need to know the liquidus line, which is this line, and we also need to know solidus line. It is over here. Over the liquidus line, we only find liquid phase only. Below the solidus line, we will find solid phase only. For the axis, the horizontal axis is showing weight percentage of nickel, and the vertical axis is showing the temperature. The value on the horizontal axis will tell you how much the weight percentage of nickel, because over here written as weight percentage of nickel. It means that at here the weight percentage of nickel is 0% and copper is 100%. Over here we have 20% weight percentage of nickel and 80% of copper, and so on, until we find 100% of nickel and 0% of copper. So what we can know from the phase diagram? Rule number 1. If we know the temperature and composition, then we know the number and types of phase present. We take the example over here. We have at point A, the temperature is 1100 degrees Celsius and 60 weight percentage of nickel. So the A is over here. As the rule said, over here we can know the number and type of phases present. So over here we only have solid only. So the number of phases present is one phase, and the phases present is alpha. For point B, the temperature is 1250 and the composition is 35 weight percent of nickel. The point B is over here. It is below the liquidus and above solidus. In this region, we have two phases, the liquid phase and alpha phase. So the answer is we have two phases, the phases are liquid plus alpha. Some common features of phase diagram. For this phase diagram, we are using alpha for solid solution. We can also use beta if the example gives the beta, and we can denote it as gamma if the example or question denote it as gamma. L is represent a liquid. For liquid, we usually only use L. For second rule, if we know temperature and composition, then we know the composition of each phase. C note is the original composition given in the question. The composition that we want to know here is how much the composition of liquid or how much the composition of solid at that region. For example, we take a look at composition 35 weight percentage of nickel. At temperature A is over here. So we draw a line from temperature A until it meet line 35 weight percentage of nickel. So it is over here. We have only one phase. The phase is liquid only. So the composition of liquid is equal to original composition, which is 35 weight percentage of nickel. For point A, we don't have composition of solid because only liquid phase are available there. For second example, we take the composition as 35 weight percent of nickel at temperature TD. So TD is over here and 35 is over here. As usual, once again, we make a straight line until it intersects. So the point D is over here. At point D, we have only one phase. The phase is solid only, or we denote it as alpha. So at point D, we have C alpha, or composition of solid, equal to original composition equal to 35 weight percent of nickel. At point D, we don't have Cl because composition of liquid is unavailable. We only have composition of solid only. For the third example, we take original composition at 35 weight percent of nickel at temperature B. So temperature B will be over here. Once again, we make a straight line until the TB intersect with 35%. So we get the point B is over here. As we can see at point B, we have two phases which are liquid plus alpha. In this case, we need to find how much composition of liquid and how much composition of solid, because we have both liquid and solid. So what we do is, to find composition of liquid, we need to make a horizontal line from the intersection until we meet liquidus line over here, and then we draw down the line, straight line, until the x-axis, and then we will find the composition of liquid. So the composition of liquid is 32 weight percent of nickel. And then for the composition of solid, we do almost the same. From the intersection at point B, we make a straight line until solidus line over here, and then we draw down the line until x exists, and we take the composition of alpha value for solid. So we get the C alpha is 43% of nickel. Please remember to find the composition of liquid, the straight line must be until liquidus line. And to find composition of solid, the straight line must be until solidus line. For further understanding, you can read the note over here. First thing, you need to locate the temperature. Second one, if one phase present, the composition is overall composition. If two phases present, use tie line. The tie line that I showed you before is on intersection until liquidus line, and then we draw the straight line downward until x exists. That is to find composition of liquid. Another tie line is we use intersection until solidus line, and then draw straight line downward until x exists, and we get composition of solid. For the rule number 3, if we know temperature and composition, then we know the amount of each phase. When we talk about amount of each phase, sometimes we call it as relative amount. For example, over here, at composition 35% of nickel, at temperature A, as usual, we make a straight line from temperature A and straight line for 35% of nickel, and then we see where it intersects. At the intersection, we must know how many phases present. For example, at point A, only one phase present. The phase present is liquid only. When we have liquid phase only, the amount of liquid will be equal to 100%. Then the amount of solid will be 0. At temperature D, over here, we have one phase, and the phase present is alpha, solid only. So the amount of liquid will be 0, and the amount of solid will be 100%. The third example is, it is still same composition, 35% of nickel, at temperature B over here. So the intersection will be over here at point B. At point B, we can find that we have two phases, and the phases available is liquid and solid. So how much is the amount of liquid phase and how much is the amount of solid phase? To find this, we need to make a tie line again like we made in the composition, but we need to use lever rule. To find the amount of liquid phase, we need to use line from point B until solidus line divided by overall line. Overall line is line from liquidus until solidus. To get this line, what we can do is we use C alpha, composition of alpha, minus with composition original, we divide with composition of alpha minus composition of liquid over here. I show you once again The composition of alpha is over here. We minus the overall composition or C node. So we will get this line only. And then we divide by composition of alpha minus composition of liquid. So we get this line. It means that the intersection until solidus line divided by overall line. Please remember to find the amount of liquid, we use the point at solidus line. It is different when we are going to find the composition before. So for the C alpha, we have 43 weight% of nickel minus with overall composition, we have 35 weight% of nickel divided by composition of alpha 43 minus composition of liquid 32. This is to find the overall length. This is to find the solidus length only. So we get 73%. It's shown here. To calculate amount of alpha phase, we need to use the line for intersection until liquidus. To get this line, we use overall composition minus with liquid composition. We divide with overall line over here. To find overall line, we use composition of alpha minus composition of liquid. So for overall composition is 35 minus with composition of liquid is 32 divided with composition of alpha 43 minus composition of liquid 32. So after we calculate, we will get 27% or 0.27. 27% means that the amount of solid phase is 27% at that point. To find the amount of phases present or relative amount of phase, we use lever rule over here. I need you guys to think for a while. Why? When we want to find composition of liquid, we use intersection until liquidus line. And to find composition of alpha, we make a straight line from intersection until solidus line. But to calculate amount of liquid, we use the intersection line until solidus line. To find the amount of solid, we use the intersection line until liquidus line. This is occurs because of lever rule. In this case, I need you guys to think for a while on this figure. Why this is happened. So that's all for this video on binary isomorphous phase diagram. We will continue with the example for binary isomorphous phase diagram in the next video. Thank you. Have a nice day.